We're not going to worry about the models on these because, well, everyone hates models. So, I'm going to scratch out that garbage.
Do you do the models on the homework?
If you want to.
Do you have to?
If you want to, you can. So, all I'm going to do is, well, some of these I may use an equation. Sometimes we may not. We just need to get them solved. And it should be interesting to note that you can check the answers on these. Just a lot of people don't, but you should. All right, today is Rose's 12th birthday. She has a savings account of $515 in it, but her goal is to save $10,000 by the time she turns 18. So, how many years does Rosa have to save now?
6.
Yeah, she's got 6 years to save. So how many months is that? Because we want to know how much she wants to save each month. Yeah? 72 months, right? How do we get 72 months? 6 times 12, right? Well, now what we need to know is how much she still needs to save. How much is needed? Well, she wants to get 10,000. And she already has 515, so what do we do with the 515? All right, so if she needs it, what are we going to do with the 515? Subtract it. So when we subtract these, then we'll borrow a 9er from right here, and up and here, and up and here. 9 minus 1 is 8, minus 5 is 4, 9 minus is 9. So this is how much money she must save if she is to reach her goal in 6 years. But she wants to do this in 72 months. So what do we do now? Divide that by 72 months. And this comes out to be, this is where a calculator becomes really nice. What is it, 121.75? $131, and we'll round that to 74 cents, because if we keep it down at 3, eventually she will end up short a few pennies. So, she must save this much money per month, is the answer right here. And we could check. We do 131.74. We'll multiply this by 8. No, 72, what the heck. 72, I don't know where the 8 came from. And what do we get out of these? 9,400 and what?
Wait, you times it or divided by?
I multiplied it. Because I'm checking the work now, right? 9,400. I got 85.28. Well, if I add the 515 bucks that she already has, then we get 8. A 2, 0, 9er. I forgot to carry the 1 right there. There we go. Then I'll carry this one and this one. Bam, 10,000. We do have a few extra pennies there, and that's okay because we had to round it. We did not use an equation on that last one, but this one we will. This one's pretty nice. No, an equation. Because we should be using equations. Because that's what this whole unit is on. Eisenhower Junior High School made 1,250 hot dogs to sell at the county fair as a fundraiser for new computers. They're only going to sell them for 2 days. On the first day, they sold 436 hot dogs. If they plan on selling for 8 hours on the second day, how many hot dogs per hour will they have to sell in order to sell the rest of their hot dogs? So there's 2 things we got right here. We got day 1, and then we got day 2. And this would be hot dogs sold. If we add the 2 days together, we should have the total number of hot dogs sold. And do we know how many hot dogs they sold on day 1? Yes. On the first day, they sold 436 hot dogs. Do we know the total? Sure. They made 1,250 hot dogs. The problem is right here, we don't know how many hot dogs they need to sell on day 2, but we do know that they will sell for 8 hours. And if we just multiply this by the number of hot dogs, x, so we'll define x equals number of hot dogs sold per hour. Well, then we will have the answer there. How many hot dogs per hour will they have to sell? That was the question. That is the variable as well, so that when we solve this thing, we have the actual answer. Well, this looks like a pretty normal equation. In fact, we don't really need the multiplication right here. And we should be looking to subtract the 436. But let's look at this in context as well. See, what happens is we drop this, right, we get 8x equals, and when I subtract these, I'll borrow 1 from right here. It's a 4, a 1, and an 8, 814. So, in context, this is just showing now what we need for day 2. And by subtracting the 436 hot dogs from the total, we now know how many hot dogs must be sold in day 2. Now, if they're selling them at 8 hot dogs every hour, well, what would we do now? Yeah?
Divide 814 divided by 8.
Excellent. Now in the equation,
Step and do,
in any case, this leaves us, see if we divide that by 8, it'll tell us how many hot dogs per hour, which was x. And that should come out to 101.75?
yes.
Alright, now the problem with this answer right here, because this is a word problem, is you can't really sell 101.75 hot dogs per hour. You need to round this thing up. So we would have to say that, in fact, they would have to sell 102 hot dogs per hour. And yes, this is a word problem, so on a test, if it was not labeled, you would be losing points. Now hopefully that made sense in context. Some of you guys wouldn't need the equation to solve that. But I hope the equation is helpful because later on, all the other classes said that it was helpful. Alright, well this person, Kalisa's Gramps, he won't tell her how old he is. What a jerk. Well, instead he told her, because he's a wise guy, I guess, I'm twice your mother's age. Kalisa knows her mom had her when she was 24. Sorry, no, yeah, that could have turned out very bad, yes. But Kalisa, is now 12. So how old is Kalisa's Gramps? All right.
72.
Yeah, okay. Well, how the question really is, how do we get 72? All right. Ava's close to me, so hopefully we can hear her on the microphone. Please explain.
Wait, so you get 72 because you have to add 24 and 12 together, and that equals 36, and 36 plus 36 is 72.
Did you guys multiply 36 by 2?
Yeah, I multiplied.
But it's different, right? No! Very good.
Technically, that's wrong, Mr. Stone.
Yep, if you do this on the test, minus points. 72 years old. Must label word problems. Alright, let's look at this just a little bit different. Alright. Up in here, let's just look at the equation. We already know what the answer is. So we know x, that should be what we're solving for, and that's old Gramps' age. Gramps' age. Gramps. Well, right here, if we look at this, we know that the mom was 24 when this person was born, right? So, if we take half of Grandpa's age, and right here, it looks like we would have to subtract the 12 out of that, which would give the mom's age. So half of Grandpa's age, we go 12 years back and we get the age the mom was when Kalisa was born.
24.
That is the equation. Now when you solve this, you'd add 12 to both sides, which is what we did right here. And then we multiplied both sides by 2, which is the same thing as adding 36. Khalid says Grandpa was really impressed that she was able to figure out his age, so he decided to give her another riddle. He's a funny guy. He said, the sum of your great-grandparents' age is 183. If the great-grandpa is 5 years older than the great-grandma, how old is each of them? Either way,
I got
good
it
luck.
wrong though, just by the way. So. Oh, let's put one here. What did I do? So I looked at the age of both of them combined, and I saw, oh, there's 2 people.
I can't hear you.
So I divided it by 2, because there's 2 of them. And I know that that's 9. I just said that they were 91 and a half. I don't know if that counts. And then the grandpa is 5 years older than the grandma, so I took 5 years away from 91 and a half and got 86 and a half. And then I added those 5 years to the grandpa and got 96 and a half.
Nice. Thank you.
Did it wrong, right?
Yeah, well, we'll see. All right, so I hear a lot of mumbling about these. So what do you guys think? Why? Yeah, good. So this is showing that they're 10 years apart when right account says 5 years apart, right? So
Wait, I know how to do it. So you wouldn't add the 5 years.
now before we have someone else try this, you need to remember as well that the 2 ages should add up to 183, right? So let's add these and see if we can get 183. Okay, that should help us as well. 0 carry the 1, that's a 3. There's another 1, bam, that's a 183. So these do check off in terms of adding the 2 ages, but one is 10 years older than the other. So we just need to fix that a little bit. All right, good luck.
Thank you. Okay, so first what I did is I did 183 minus 5, and you get 177. And then what I did was I did 177 divided by 2, and you get 88.5, but then you have to round it, I'm pretty sure. And I got the grandma's age is 89. And the grandpa's age is 89 plus 5, so it's 94.
All right, let's check. Let's check and just make sure it works, right? So does it show that Grandpa's 5 years older than old Grams? Sure do. What if we add these 2 ages together? 9 plus 4 is a 13, carry the 1. 183, so that checks off. There was just one thing in here that I want to point out. That wasn't really it. There was something a little bit else that we should look at. It's the 183 minus 5, that'd just be 178. Right there. Now that would have given you a straight up 89er right there. And that would have been it.
I got it.
That's it. So yes, that is correct. Grams is 89, Gramps is 94.
Wait, so how
Peter tends a total of 87 sheepses and goatses. That doesn't mean there's 87 of each.
one of those?
I think I have.
I made a lamb.
I'll eat whatever. Okay.
Would you? He never said it was
All right.
a lamb.
Well, okay. Anyways, I just needed to point out that that doesn't mean there's 87 sheep and 87 goats. Just if you count all the animals, then you'd have 87 of them. Okay, he had 15 more sheep than goats. We probably ate them. Well, that's what I would do, right? Aren't goats the male version of sheep?
No.
Is that wrong?
Yes. Goats are the one.
Then are sheep female version of goats?
No, that's wrong.
I don't even know anymore.
Neither do I. That's what I'd like to know, though. But I'm also too lazy to look it up. Anyways, how many sheep and goats does Peter have? Good luck.
Thank you. Okay. So what I did is 87 minus 15. That equals 72. And then I did 72 divided by 2, and that's 30. It's 36. And then 36. Wait, hold on. Let me just write this. 30. Wait, where am I? 36 plus 15 is 51, which means there's 51 sheep and 36 goats.
Bam. Yeah, how do we check?
Congratulations, Ava.
How do we check these? All right.
You said shut up.
Yeah, when we add these, we get 87. That's what it said. There was right account. So yes, that checks off. Bam. There it is. It also says that it's 15 more sheep than goats, right? So 36 plus 15 is the 51. Peter's neighbor raises chickens, both hens and roosters. Their family sells eggs, so they like to have 4 times as many hens as roosters. If they currently have 45 birds, how many are hens? I like eggs. I like the eggs when the yolk is not cooked all the way through, you know what I mean? So it's like runny, so that when you bite into it, it like explodes into your mouth. Yeah. I like to put eggs on top of Spam, on top of rice. That's an old-fashioned Polynesian treat. Yeah, I eat it for breakfast.
Do you eat the rice?
So I get a full can, and then my kids get a different can.
Do you eat the seaweed and Spam and rice?
Yes.
They're
A Spam roll, they are good. Because, well, it has Spam. Spam is an amazing meat. Spam is meat in a can. Spam has to be healthier than all the McDonald's meat you've ever eaten. You could get Spam. You could eat Spam every day and probably not die. You could eat McDonald's every day and then die. Thank you.
Okay, thank you. Okay, so if you have 45, and you divide that by 5, it equals 9, and then you do 9 times 4, that equals 36, and then if you do 45 minus, 36, that's 9, so there's 36 hens and then 9 roosters.
Why'd you divide by 5?
Because if you do, it said they have 4 times as many hens as roosters, so if
Oh, makes sense.
Yes, that is correct. All right, so some of you guys are confused why we divided by 5 right here. And the equation hopefully would help that, right? We got hens, and then we got roosters. And right up here, it says there's 4 times as many hens as roosters. So if we said roosters is X, then hens would be 4 of those X's. And when we combine these, we would get 5 of these X's, which is why we divide by 5.
Yes, it is.
All right. No, it is fresh. It comes right out of the can. Like once you open that can, it's the first time it's ever been opened. Bam, fresh.
No, it's not.
It is fresh.
First time it's been opened.
As it turns out, you can eat Spam raw as well. Like you can just chop off a piece and pop it in.
Wait, if there's
I had not eaten Spam today, but I did eat some meat.
is the chicken in Spam cooked?
Yeah, you can. I don't know.
If the chicken's not cooked, then you can't eat it.
Well, you develop a certain
Ew.
resistance to the uncooked portions. Number 7, James is 5 inches taller than twice his height when he was 3 years old. If he's now 5'10", how tall was he when he was 3? Take a moment and do this one. All right, up in here, we got 5 foot, 10 inch. So I'm just going to convert this into inches so that we can just work with one type of length. 5 foot, that would be 5 times 12, which is 60 inches. But then we got to add the other 10 inches, which makes James 70 inch. All right, now this is after the growth. Now we know that James is 5 inches taller than twice that height from 3 years old-ish.
How did you get 60?
So we got to work backwards. So first thing we should do is, remember, it's twice the height and then 5 inches taller. So I'm going to take off the 5 inches first, which give us 65 inch. Now it says that would be twice that height from 3 years old. So I'm just going to take these and divide it by 2, and I get 32.5 inch.
Wait. I got it right the first
Now,
time.
we should check this by doing what it said, 5 inches taller than twice the height. So if we take that 32.5, and this is just checking, right, we're going to double that. So multiply this by 2, which gives us 65 inch. But then it said it was 5 inches taller than that, so we'll add the 5 right here. And behold, 70 inches, which is what we had right here.
So we use 70 inches.
So this checks off 32.5 inch is how old James were at 3 years old.
I almost read the first. Yeah. You
So height, I mean, yeah, how tall and how old. He was 3 years old.
How old?
So these problems, we're going to skip 2, by the way. These problems are very similar to what we did on the bell work, which is good. Because in these equations, we're going to have x's on both sides of the equal sign, and we've got to be able to know how to do that. So, right here, number 1, for example, we got 3x plus 4 equals 9x minus 20. Well, the problem with this is that we got the x's on both sides. So let's get rid of the x's on one of the sides. And to do that, we will use the t method. The t method, right here. So do we want to get rid of the 9x or the 3x? It doesn't matter, by the way, which set of x's we get rid of.
3x.
Let's get rid of the 3x. How do I get rid of 3x?
You divide it by 3.
That's close. That would give us 1x.
Minus.
So I need to make it a 0 by subtracting 3x. But if I do it to one side, gotta do it to the other side as well. Now 3x minus 3x is 0. We still got the 4, which will drop right here. We just brought the equal sign down with the line. 9x minus 3x would give us 6x's, and then we got the minus 20 right here. Now for these, we got to remember that each term carries the operation immediately to its left, so that's a negative 20, not a positive 20. Well, this looks like a regular old-fashioned equation, which you guys know and love. And from right here, would use t method again. But now we got to get rid of that minus 20 by adding 20 to both sides. So I'll drop my 6x right here. And 4 plus 20, 24. Now, we'll divide both sides by 6. Because 6 divided by 6 is 1. That's 1x. That's good. 24 divided by 6 is 4. And yes, I don't really need the 1 there. So x equals 4. 4 equals x. It is the same. No. Yeah, see, so this 3x is on the opposite side of that 9x. If I just combined it and said I got 12x, then it's more like an expression, not an equation. So to maintain balance or equality, we've got to subtract 3x from both sides to make it a 0. So the objective here, the first objective is to usually get the x's on their own side of the equal sign, which is what that 6x is. All the x's are on one side, not on both sides. All right, 21x minus 8 equals 17x plus 24. Now remember, we don't want x's on both sides of the equal sign, so this is why the T method is so nice, is because it shows us each side of the equal sign. So do we want to get rid of that 21x or the 17x? Again, it doesn't make a difference, but you get to choose. 17x. How do I get rid of 17x? Minus 17x. But if I do it to one side, gotta do it to both. And that becomes now a 0 right here. 21x minus 17x's gives us 4x's. Then we got this minus 8 equals, we'll drop this 24 right account. Now that 0 just goes away. It's the additive identity, so we don't need to write it in. And from right account, we'll add 8 to both sides to get rid of the minus 8. And we're left with this 4x equals 32. Then we'll divide each side by 4. And we see then that x equals 8. All right, you guys take a moment and try these. All right, here you go. Good luck.
So we have to add the t. And what we have to do first is we need to add 4 on both sides. And that would be 24, and that would cross that out. So 24 minus 4x equals 8x. And write smaller. Then you do the t again. And this time you can add 4x. So that would cross that out. And then adding 4x would equal 12x. And so then that would just leave us with 24 equals 12x, and then you divide them both by 12, divided by 12, and that would equal 2, so 2 equals x.
Bam. Excellent work. Good old Fiver. I like what was done on that last problem because you can get rid of the numbers first if you want, or the x's. There's so many options on these, which makes it so nice. So the question for you guys is, what do you want to do first? All right, minus the 6x, so that's a negative 6x. I'm sorry, so I'm going to add 6x. So that will become a 0 right account. So we got this negative 8 now equals, this will be a 2x right account. Negative 4 plus 6 is positive 2 for us. And then we got this minus 20, which will drop right account. Well, we got to get rid of that 20, so we'll add 20 to both sides. And that gives us 12 equals 2x. And divide everywhere by 2. And we get x equals 6. Now here's the thing is, let's say that in the beginning you added 4x instead. Then when you get to this point, you may have had negative 2x equals negative 12. But when you solve that one by dividing both sides by negative 2, you still get the 6. Right there. X is 6. Alright, what do you guys want to do on this one, Foist? Minus the 7x. Let's do it. Subtract 7x. Subtract 7x, so this becomes a 0. 8x minus 7x would be 1x. Minus the 9er. And then we'll drop the 43. This equals 43. Now what?
You add 9.
Add 9er. So we got this 1x equals 52.
So X.
Now we could divide both sides by 1 or just make it a phantom 1. Bam. Done. What, Foist?
Subtract 17.
Subtract 17x. Let's do it. So now we got this 2. Negative 43x's minus 17x's gives us negative 60x's. And this now equals this 32. Backwards. 32. So now what? Well, I would say subtract 2 from both sides. So this becomes a 0 radical. We're left with negative 60x equals 30. So we'll divide both sides by
30.
Now if we divide it by 30, we'll still have a negative 2x's though. So to make that a 1x, we'll divide both sides by negative 60. And we get x, or 1x, equals negative. If we simplify these, we can divide both these by 30. And we get negative, not negative. Yeah, dude, it is negative. Negative 1/2. 30 divided by 60. Alright, there's all three of them. Bam.